Welcome everybody to Digital Beats, where we discuss the latest in technology, news, and innovative trends in digital transformation. Today's discussion will be super interesting. We'll be talking about key technologies in next generation enterprise level databases. Let me introduce you to our guests. Dr. Feifei is Vice President at the Alibaba Group. He is the president of the Database Products Business Unit of Alibaba Cloud Intelligence. He is a multi-award-winning scientist, and he leads R&D on cloud-native database systems and products at Alibaba. Also joining us is Charlie Dai. He is the principal analyst serving enterprise architecture professionals at Forrester. He is a leading expert in cloud, big data, AI, IoT, blockchain, and many more. And Charlie is also an avid tech blogger with millions of readers worldwide. So Charlie, what's your definition of cloud native computing?
Yeah, thanks, Milo. And cloud native, it is one of the hottest topics we have been seeing in the past 12 months. And currently I'm leading the global research about the cloud native within Forrester. And referring to the definition from the CNCF, the Cloud Native Compute Foundation, cloud native technologies empower organizations to build and run the scalable applications in a modern and a dynamic environment, such as the public cloud, private cloud, or hybrid cloud environments. And these technologies normally include containers, service mesh, microservices, immutable infrastructure, and some of the declarative APIs. And the core of the cloud native are three different characteristics. One is to enable the loosely coupled systems. And these systems are also resilient, manageable, and observable. And then it is about how to use the robust automation for all kinds of infrastructure and application workloads there. Actually, before cloud native, the big data and the database are already accelerating the migration towards the public cloud space, because public cloud obviously can provide us the on-demand provisioning through the self-service, as well as to help you jumpstart your innovation, to have the synergy with all other different technology ecosystem like machine learning or IoT, as well as the better cost effectiveness, to avoid the CAPEX with the better OPEX sort of thing. And this means that the positioning of the cloud has changed from the infrastructure optimization to the value foundation for the modern adaptive enterprises as defined by Forrester. And with cloud native, not only the landscape of the cloud itself has been fully disrupted, but also all the major technology areas, including database and big data, are also being transformed. So, for example, like the containerization of or some of the bare metal support can provide better performance for the resource pooling than the virtualization. And secondly, from the architecture perspective, the separation of the computation from the storage with the shared storage will provide a horizontal scalability in the distributed environment. And Feifei mentioned the share nothing and share everything, and also plus the read-write splits with RDMA network. And all these will help you to manage your workloads within the distributed environment. And the third one we think would be around, like containers and the Kubernetes, and the serverless will help you to further auto scale for better elasticity, which is critical for the highly dynamic workloads. And we also mentioned about automation capabilities powered by machine learning and deep learning for the big data or database provisioning, and cluster management can further help you to improve the efficiency and the predictability so you can have a consistent user experience for your customers. And the last but not least, we think cloud native provide a bridge which will span the distributed environments from cloud to edge and on-premises. So all these, to summarize, are critical to satisfy the customer needs.
So Feifei, another question. What problems will cloud native databases solve that traditional databases cannot?
Yeah, I think building on Charlie's explanation, I think Charlie did an excellent explanation of what cloud native is and what cloud native does. So building on what Charlie has said, cloud native database system compared to the traditional on-premise relational database system, there is one very important distinction, which is cloud native database system builds on the idea of decoupling the resources in your system. For example, decoupling or separation of computation and the storage by leveraging the underlying IaaS infrastructure, infrastructure as a service from a cloud infrastructure. By decoupling storage and computation, you can offer much better elasticity and high availability. And then together, working together with other technology we have mentioned, for example, share nothing for horizontally scaling out using distributed technologies, and then using container and Kubernetes for easy deployment and orchestration, and using serverless to support on-demand usage of resources, and then auto-scaling automation to make the running and orchestration of your database system much easier than before. So those are some of the key features you can see you will expect from a cloud-native database system. Compared to a traditional database system are built based on the tight coupling of all the resources in your system. So there's no separation of storage and computation, for example. There are no auto-scaling. There are no container deployment with serverless support. So the way to understand the distinction of the two, if you allow me to give you another metaphor, it's kind of like the traditional database system is kind of like digging a well in your backyard when you want to use water. So you dig out a well and the well supply water to your kitchen. And then you are facing a really tough challenge, which is how deep or how wide that well should be. Obviously, the decision is to be made with respect to how many people are in your household, because that determines how much water you need. So you will dig the well based on that capacity assessment. But a big challenge, though, is the number of people in your household may change. You may throw a party and a lot of people coming into your house, and you need a lot of water. But you only do that once in a while. You don't do that all the time. So what do? Do you dig a well that's big enough to support the peak workload needs from that party? But then for most of the time, you end up wasting resources because you don't have that many people using water all the time. Cloud native database system solves that problem. You are no longer digging a well per se. You are getting water from a pool of resources. You are getting your water from your tap. When your tap, water come out. Whenever you finish using the water, you close the tap. You're done. So it's kind of like you centralize. You put all the resources from separate wells. You may have hundreds or thousands of different wells. You put all those water from all those wells into one central repository. Then you build separate logical well. They are separate, but they don't have any water in it. Rather, they tap resources from this central repository, then in an on-demand, elastic fashion. So you can satisfy your system needs based on the dynamic workloads that change over time, rather than work for a fixed workload all the time. So that's the biggest distinction between cloud native database system and traditional database system. This allows you to utilize your resources in a much elastic and effective fashion so that your TCO, total cost of ownership, will be dramatically reduced. That's one really, really important distinction. Of course, there are many other benefits. For example, auto scaling, ease of orchestration and management. And I will stop right here, but that's really a really, really important distinction between the two.
Yeah, sure. I think that's fascinating. And again, thank you very much for another metaphor. I'll be using that one as well. Charlie, many enterprises are starting to adopt cloud native databases. What do you think is driving that?
Yeah, thanks, Milo. And by the way, I also love the metaphor from Feifei because the water can definitely have the elasticity that we are looking for. And that is part of the drivers to adopt the cloud native databases because in the world of the martial arts in China, there's a saying about, only fast is unbreakable. And the need for speed is so important. It means two different things. One is about the performance, how to run your workload is in a much more effective way. And one is about the elasticity, how we can be like water to scale your workloads, to scale your cluster and support your workloads there and make sure you have the consistent performance for your enterprise customers. So this is all about the customers, how we can have a better customer experience for your transformation, how we can improve your operational excellence within your company so you can have better equipment and better scalability for your overall transformational workloads. And all these actually comes back to where we are right now, especially during the COVID-19, we are in the world of the uncertainty and we have to be adaptive towards this kind of challenge. And many companies are talking about how to become adaptive. And we think this kind of cloud native technology, which will power the database, big data, and all other different technology areas will help us to accelerate our transformation toward that kind of adaptiveness in this kind of uncertain world.
Right, fascinating. I use the water metaphor all the time. Feifei, traditional database architectures have gone through a lot of iterations. And so, today database as a service is increasingly popular on the cloud. Are you seeing an evolution in cloud native database architectures?
Yeah, I think, as we have discussed in the last part of our conversation, cloud native database system builds on this idea of decoupling of your resources, for example, decoupling computation from storage, and then build resources into a repository, just like water for processing facility versus separate wells. But on top of that, the innovation does not stop right there. We have seen new trends coming out of building next generation cloud native database systems. One thing we already talked about, which is integration of big data and database technologies, or building HTAP cloud native database system. We talk about that. Then another trend moving forward we have seen is to use AI and machine learning technologies to make automation, auto scaling of cloud native database system much easier than before. So for example, it's just like you are using AI and machine learning technology nowadays to monitor your water processing facility for a city so that you can better predict which district gonna need more water, which district gonna need less water, so you can intelligently allocate your resources throughout your system such that resource utilization is maximized. It's actually exactly the same way. We can use AI and machine learning technologies to integrate those with cloud native database systems so that we can have better auto scaling services and management for application running on top of cloud native database systems, so that we can maximize the efficiency of utilizing resources in a cloud native database system, and that deliver the most value to our customers. So that's definitely a trend moving forward. Just like you have self-driving cars nowadays, like Tesla, we're gonna have self-driving database systems. This is only made possible with a cloud native design because the allocation and deallocation of resources is really, really flexible. And this gave out a lot of room for making intelligent and machine learning driven decisions so that you can utilize and allocate your resources in a very precise and fine granularity level. So self-driving database system will be a big trend moving forward in cloud native database space.
This self-driving database, what what will this lead to? I mean, what are the possibilities of that sort of type of database?
Yeah, just like when you have a self-driving car, what would you think of the car? Well, it changed your steering wheel for you, so you don't have to put your hand on the steering wheel all the time. It helps you remove your foot from the gas pedal and brake pedals because it knows when to accelerate, when to brake, so that you can rest at ease and only intervene when needed in emergency situations. So that free up you, improve your efficiency and free up your labor costs and so on and so forth. So that's what's going on in a self-driving car, very easy to understand. In a very similar fashion, in traditional database systems, we need a lot of fine-tuning of the system to get the best performance out of it. For example, what index to build, what should be the buffer size, how to partition my data, what kind of slow SQL statements are running in my system, and how to optimize those SQL statements so that my efficiency, my query efficiency and query performance can get improved. But when you scale this out to a large scale of data processing needs, obviously this will be very costly and even not scalable to a point. With a self-driving database system running as at the bottom for you applications, you don't have to worry about a lot of those issues I have just mentioned. For example, it will automatically recommend to you what index to build. It will automatically partition data for you based on your workload needs. It will also automatically identify what kind of slow SQL statements are running in your system and how to fine tune your system parameters to make those queries run faster for you. So it's all about make it easy to run and manage big database system. It's all about improving the efficiency and effectiveness of your system in a data-driven, machine learning-driven, AI-driven fashion.
Thank you, Feifei and Charlie. Thank you very much for your time today. It's been a really great discussion. I just want to say one thing to the audience. Hey guys, don't forget to catch the next episode of Digital Beats, where we'll discuss more trends in the cloud.